Hi everyone, thank you so much for having me here at Women Who Code. My name is Izzy Briant and I'm a senior iOS engineer at Depop. I'm excited to talk to you today about the challenges of mobile development and how I've overcome some of those challenges with specific examples from iOS. So first, a little bit about me. I'm an iOS engineer at Depop, and I have a background in music and electronic engineering. I started as a software engineer on a grad scheme before becoming an iOS engineer. And I want to talk to you about the challenges of mobile development at scale. So I'll take you through releases, some challenges with versioning, third-party frameworks, app state, and crashes. So first up is releases. So some of the challenges of mobile releases is the nature of the release is very slow when you compare to backend or web releases. This is because the review process can take days. There are App Store guidelines and policies to adhere to, which may be unexpected and could delay your release. User adoption is not immediate, so you can't guarantee that your users will be on the latest version of your app. And you can be slow to react to live issues because it takes days to get a new release out. And the other challenge to mention is supporting multiple versions. So what could some solutions to these challenges be? For speed, you can automate the upload process, and this removes a lot of the manual steps from the release process. You can use a phased release, which allows you to release your app to, say, 1% or 50% of the users and gauge the stability of that release before rolling out to 100%. And another solution to improve the reactiveness of your app once it's released is to use feature flags or experiment flags. So you can put your experiment or feature behind a flag, and this can be remotely controlled. And it's really good because you can target really specific criteria. So you could release something to a certain app version or iOS version, or users in a certain location to test out a feature before going live to everyone. So feature flags sound great, but they have their own challenges. Your services must support these flags in previous versions for a long time. So this leads to a buildup of tech debt and cleanup, and maybe engineers move and knowledge is lost. So you have a lot of flags in one place and you're not sure if they can be cleaned up or not. So one solution to this could be a forced update mechanism. So this is where your users will open the app and it will present a screen blocking any interaction until they update to the latest version of the app. So this ensures all your users are up to date. But the problem is this must be prepared in advance, so you can't wait until you need it to use this mechanism. It also disrupts the user journey. So here's a fun question about releases that you might want to ask yourself. Who is responsible for managing the Apple developer account? It might seem like an obvious question. It could be iOS engineers, maybe a platform team, maybe someone else. But it's an important one to ask because a few months ago, the Depop app was removed from the App Store for a few hours. And this is because we failed to renew the Apple developer membership. So even at large companies, mistakes like this can happen. The next challenge I want to mention is supporting iOS versions. So usually we support the latest 2 or 3 iOS versions, which are released every year. So currently this would be iOS 14, 15, and 16. However, this depends a lot on your app and business requirements. So you need to think about things like how tech-savvy your users are, how often they update their device operating system, and also how often they update their models of devices, because major hardware or software changes can impact how your app functions on a different OS. So in terms of hardware changes, we're talking about things like moving from the iPhone 8 to the iPhone 10, where we introduced a notch. And this completely changed the way we lay out the UI, so all of these screens had to adapt to this new layout. You can also think about the processors in new devices, which affects which iOS versions and therefore features of the code you can run. So with a new iOS version comes a new Xcode version, and with that, we need to migrate a team of engineers onto the new Xcode version all at the same time. And it's likely that there'll be a new Swift version to migrate to as well. So you need to ensure that your app runs in this new Swift version. And when there are major releases in iOS or Android, you need to ensure that your app runs on this new version without any nasty surprises. So in terms of solutions for this, the only one I can suggest is to be prepared for these new major releases and try to run your apps as early as possible. So the next challenge I want to talk about is third-party frameworks. Third-party frameworks have many benefits for your apps. They can enable new functionality and features. This saves you time because you don't have to develop the software in-house and you get it for free. And they can enable lots of large cross-functional projects. So you're likely to use third-party frameworks for things like analytics, push notifications, image download and caching. But they come with their own risks. One of the biggest ones is security and privacy. So you need to ask who wrote that code. Could there be anything malicious in that code? Will it have an effect on your business? The other risk is performance. So from my experience, third-party frameworks can introduce a lot of crashes and memory leaks. So that's something you need to consider. Is it worth the compromise for this feature? They also require updating and maintaining, so when there's a new version of the framework, you need to ensure your feature still works. And you need to hope they support the desired dependency manager for your app. So I'm going to take you through an example in the Depop app of a third-party framework. So JSQ Messages View Controller is an open source library that we use for the chat in Depop. So here's a conversation in the Depop app between two users, and the UI of the screen is using JSQ Messages View Controller. However, this library was deprecated since July 2017. It's written in Objective-C, it has compatibility issues with new iOS features, and that meant we found a lot of bugs in iOS 14. So I made it my goal to replace it as soon as possible. After looking at a lot of alternatives, my proposal was MessageKit, which is another open source library that's intended to be a direct replacement for JSQ Messages View Controller. The advantages of MessageKit were that it supports new iOS versions, it supports the latest dependency manager that we were using, which is Swift Package Manager. It's open source and well maintained, and it enables usage of new iOS features and new Swift APIs. So we could enhance the functionality with things such as context menus, more customized designs, and we can add support for new message formats in the future. It also enabled other engineers to add new features to the code, things like link recognition, context menus, like I mentioned earlier. And during a hack day, one engineer added images into the chat, which is not live yet. So the next topic I want to talk about is app state. Mobile apps have a state and a life cycle that they go through. Your users can enter the app from any of these states, so it could be a fresh launch, they could be in the foreground, in the background, it might be through a push notification or a deep link. Your users might not have internet connection, it might be in low power mode, there might not be much available memory, and they might have different device CPU speeds. So all of these things together can trigger non-deterministic order events in the app lifecycle, and we need to be able to handle them, but it's difficult to test all of these states that users encounter. Another thing that affects the app state is local storage. So every user will have a different experience depending on what's stored on their device. So you might use local storage for caching things, it could be something in user defaults, it could be a local database. And this leads me on to a topic of data migration, and I want to take you through a real example in the Depop app of a data migration that we performed. So this example covers the draft listings feature in Depop. So as a seller, you can create a listing on this screen. You can save it to drafts and it will appear in this list here. And then from this screen, you can post the draft or delete the draft. And when we tap Save to Drafts, this performs a save to a local database on the device, and it also syncs it with a backend mobile API. So that's great, but when we're offline, there's a slightly different flow. So if your user has no internet connection, they create the draft and save it. We save it locally in a database, and we were using Realm, which is a third-party database framework. And then once the user reconnects to the internet and they're either on the draft screen or they relaunch the app, then we sync with backend. But this syncing algorithm was complex and difficult to debug. And new issues kept popping up, so for this reason, I added some analytics into the code to understand how many users were interacting with drafts when they were offline. And the answer was very, very few. It was 0.08% of users. And another issue is that local storage is limited on the device. So there's only so many images or drafts that you can save. So I made it my goal to remove the offline draft storage and switch to the mobile API. This will simplify the client code, make it more readable, and allows us to use new Swift APIs for things such as async await. So what's this got to do with data migration? Why do we need a migration? We perform a migration to prevent a loss of data for items that have not been synced, and this is per device. So how did it happen? So your user launches the app, and we read the drafts from local storage. We then sync the drafts with backend, and then set a local isMigrated flag on the device, and this persists between sessions. We then call the new APIs for all future drafts interactions. But there are a few things to consider. So one is the time taken for users to migrate. We released this code with the migration about a month before a cross-team dependency was due to be released for a new feature on listings on web. We also need to consider cleaning up the migration and also cleaning up the local database. So next up is crashes. So mobile apps crash, and we need a way to monitor that. So we can monitor them with tools such as Firebase, which upload crash reports to a dashboard. But some challenges are involved. So the stack trace that's uploaded can be very cryptic and can leave us no clues as to what's causing the crash. For example, here's a crash from a core foundation library, which is an internal iOS library. and another one from Swift UI, which leaves us no indication of where the crash was happening. So how could we tackle this? One solution could be to add more detailed logs. We could also check what's happening on other threads. Maybe there's some clues as to what else could be causing the crash. Or we could use tools that provide more context around the user journey, such as Embrace, which provides a user timeline and we can understand the events that led to the crash. So to take you through a real example, I'll show you how we monitor the crashes during the release process at Depop. So we have weekly releases. This means we create the new release build, and when it's ready, we release it to 1% of the users. We monitor the release for spikes in crashes, and we have a threshold of crash-free sessions above 99.7%. So if they fall below this value, we pause the release, investigate the crash, and create a hotfix, and then follow the cycle again. If we're above this value, then it's all good. We release to 100% of users. Another example is the Facebook SDK. So back in 2020, a lot of apps that used the Facebook SDK for login or analytics were all crashing. So this included apps like Depop, Spotify, Pinterest, TikTok. And this is all because of a third-party framework they added into their app. So this links back to the risks of adding third-party frameworks into your app. And a solution that we implemented at Depop was to put the entire setup and login of the Facebook SDK behind a feature flag. This meant that we could remotely control it and turn it off if it ever happened again, and users can still log in to the app through other means. So just to dive a little bit deeper into how we actually debug crashes. So here's an example of a piece of code I was working on recently in the product service, and a crash that occurred after doing this work. So we can see here in the stack trace the module that the crash is happening, and the class and the function. We can also see which versions are affected. So when it came to debugging it, I knew that the app crashes when it was handling a notification asynchronously, which points to a memory leak. So to confirm my suspicion, I enabled the thread sanitizer in Xcode. And after performing certain actions, I could see these warnings appearing. And this essentially means that updates to reference objects must be performed on the main thread to prevent the data race. So this was fixed in the next version and the crash no longer appeared. And Xcode has a lot of great debugging tools, specifically for memory. You can enable things like looking for zombie objects. You can investigate the memory graph to see memory leaks and retain cycles. You can go one step further and profile the app with instruments. You can see at the top here, it's sampling the memory leaks once every 10 seconds. And it also provides the stack trace and a diagram of where the leak happens. So to sum up what we've been through, we spoke about releases, versioning, third-party frameworks, app state, and crashes, and all of the challenges involved. And we spoke about some solutions, so things like speeding up the release process through automating the build, using phased releases for more stability, being prepared for major updates in software and hardware, assessing risks of including third-party frameworks in your app, using feature flags to toggle features remotely, and monitoring and debugging crashes. There's many more challenges I could mention, and you will face when you develop your own mobile apps at scale. These are things like performance, push notifications, deep links and universal links, offline support, localization, and accessibility. Thanks for listening.